Okay, before we begin this review for your final exam, I just want to give you a few words about what that final exam will consist of. The final exam, of course, is May 11th, and so it'll be available to you starting at 5 p.m. next Monday, and it'll consist of 80 multiple choice questions and 5 problems. The majority, the plurality, of the final exam will consist of the material and homework that we've covered on April 20th through May 11th. So the homework that was due May 20th, the homework due May 27th, the April 20th, April 27th, May 4th, and May 5th. Okay, there will be 40 questions on that section. There will be 20 questions over the material that you covered in Test 3, and there will be 20 questions over the material from Test 1 and Test 2. So that will be the multiple choice questions. There will be 2 of the problems based upon material that we've covered in the homework since April 20th. 2 problems for the material that was covered through Test 3, and 1 problem through the material in Test 1 and 2. So hopefully that'll give you a good idea about what the different things are. Of course, you can use your a periodic table with this test. Now let's go through this homework and see where everything is with this. This is the material that was on April 20th, and the first one, the answer is C. Iron is the reducing agent and oxygen is the oxidizing agent. And that's what a lot of these consist of right here, is just what are the different ones on these. Reducing agent for number 2 is the methanol. That's the reducing agent. The oxidizing agent for 3 is B, oxygen. Number 4, propane. What's undergoing oxidation? That is CH3, CH2, CH3, which is the propane. Propane is what is being oxidized. What is undergoing reduction? That's the oxygen. That's B. 6, it's snow, ice, and salt mixtures is the answer there for number 6. Number 7, I think that this one, most of you had trouble with this one. It's the oxidation of hydrogen. When they talk about oxidation and reducing agents, that's what they're talking about here. Okay, so you've got CO2, yes, but the hydrogen is what is being oxidized there. Okay, and then we have number 8, and the answer there is B, the salt bridge. Number 9. It's the anode terminal for the oxidation, and it's the cathode terminal for the reduction. That's for 10. Electron flow, anode to cathode. That answer is A. 12 is potassium nitrate. Okay, it has to be a salt. Okay, so and neither one of these other 2 are salts. Neither one of these will conduct a charge. It has to be an electrolyte. The following can be used in an electrolyte and a salt bridge, and that's sodium chloride. Again, those 2 cannot be. And then this right here is 14 is B. 15 is A. The cathode is the positive terminal. That's B. 17, it's the cathode terminal. 18, and the reason why that's got a check mark is because we'll be going over that in more detail later on. But the answer is A, 1.103 volts. 19 is B, 0.46 volts. Number 30, the answer is A, lead. Number 21, the answer is B, H2O2. It's the hydrogen peroxide there. 22. The answer is A, minus 88.8 kilojoules per mole. 23 is minus 149 kilojoules per mole. Number 24 is C, minus 213 kilojoules per mole. The strongest oxidant here is nitric acid right here. Okay, the strong acid commonly used in automobile batteries, that's sulfuric acid. That's answer is B. 27, the answer is B. Okay, there's just slight differences between these. Undergo a reversible, okay, it's a reversible redox reaction that you do on a rechargeable battery. It's not a redox, it's not a double replacement. It's a reversible redox. Okay. Number 28, the answer is C, a redox reaction. Number 29 is -1, B. And then we continue on. Number 30, the answer is B. And this right here shows you exactly how you do the electromotive force at one minus the other, right? The cathode minus the anode to give you what the values are on those. The Gibbs free energy equals the number of moles, the constant, right? And then the electromotive for the cell. F is always 96.485 calories per mole. And then what I will do is if there is on the test, I will give you values such as that one. You have to know that that particular one involved 2 moles, okay? So it's -2, 96.485 calories per mole, coulombs per mole, and then 0.486 kilojoules per coulomb to give you this value. Same type of calculation for the next one, for 23. And then what you do for the last one is because you are calculating the same type of a thing there as well, each time using the different values that you are given there. Okay, so let's go on to for homework for April 27th. This is where we have the representative metals, metalloids, and all of that. First one is, the answer is B. It's SO2. Gases are flammable. Only hydrogen of those is flammable. If nitrogen would have been flammable, we wouldn't be able to live in our atmosphere. It's considered inert. It's nitrogen. So hydrogen here, nitrogen here. Which of the following does not exist as a diatomic? It's neon. Okay, which of the following diatomics is an inert? That is nitrogen. The most active ingredient, most solid antacids, that's calcium carbonate. That's what gives you the little fizz. Okay, because we've all seen how the carbonate ion releases the carbon dioxide. Which of the following are considered toxic heavy metals? It's A, lead, cadmium, and mercury. Iron is not a toxic heavy metal, and calcium is not a toxic metal, right? The only one that has all three that are toxic heavy metals is this one. Okay, the next one, magnesium and nitrogen form magnesium nitride, Mg3N2. What is the electrolytic cell used to commercially prepare metallic sodium? It's the Downs cell, not the Herbert Dow cell, the Downs cell. Number 10 is the Haber process. Number 11 is the Ostwald process for converting ammonia into nitric acid. To isolate aluminum, that's the Hall-Hérault cell. And the commercial process for mining free sulfur, that's the Fraiche process A. The produce magnesium through thermal reaction of magnesium oxide and silicon, that's the Pigeon process. Which chemical is the greatest amount annually produced in the world? That is sulfuric acid. The intermediate that ensures no explosion takes place between sulfuric acid and sulfur trioxide is oleum. First inexpensive process for producing steel from molten pig iron is the Bessemer process. Then we have the Claus process for the desulfurization of natural gas and crude oil. And that's used to produce that sulfur. We now have the hardening That is calcium carbonate plus water, and that's a completely balanced equation there. This one right here is completely balanced as well. It's calcium sulfite is what is produced here. This one right here, many of you forgot the 2 in front of this. Okay, if you have Na3 here, you've only got one Na there and one Na there, so you need 2 of them here. That then gives you enough to balance this 2 carbon dioxide and 2 H2O. Okay, so it's a balanced equation is 2 of these, 1 of these, 1 of these, 2 of these, and 2 of these. Now the next one is there's 3 steps to this one. First of all, you determine the fraction that mercury makes up of mercury chloride. We had this way back when we were first working with these sorts of molecules. The molecular weight, or actually the atomic weight of mercury, is 200.6. The atomic weight of chlorine is 35.45, and you've got 2 of those, so that it becomes adding these 2 together to give you this weight for the molecular weight of mercury dichloride, right? Then the fatal amount is 0.2 grams of this. So this is 73.88% of this right here. I guess I should have figured that. So that's the weight of the mercury divided by the molecular weight of the mercury dichloride times 100% gives you the percent of mercury in mercury dichloride. And since this right here is the fatal amount of mercury dichloride, it means that this many grams provide the fatal dose of mercury. Now, if it's 30 parts per million, that means you have 10 to the 6th for every 30, don't you? So you multiply that factor times your number of grams that it takes, because this gives you how many grams it's going to take of the fish, right? Number of grams of the fish per grams of this one times this grams that you're given gives you how many grams total of fish you have to eat. So it's 4.9 times 10 to the 3rd grams, or 4.9 kilograms of fish that has to be eaten. Okay? So on to the next one, May 4th. The molar mass of isopropyl alcohol, you just have to add them all up, and it's 60.1 grams per mole. Okay? So the carbon atoms can be formed so many different organic compounds because they can combine with up to 4 other carbon atoms as well as other kind of atoms. Okay, not these other ones. These are not the reasons. It's A. Number 3, same molecular formula but different structures are known as isomers. C. Which of the following is incorrect for an alkane? An alkane is C sub N H 2N plus 2. So if this is 1, 2N plus 2 would be 4. 2 here, 2N is 4 plus 2 would be 6. So this is not a correct formula. These other ones are all have the CNH 2N plus 2 for them. Okay? There was some confusion on that one, it appeared. Which of the following is most stable? The most stable is this one right here. When you have double and triple bonds, as these would have to have, it has to be something like this as the most stable. Continuing on, which of the following is found in gasoline? C7H16. This right here would be a gaseous material. This right here is in your octane rating. Or would you have burn there? This right here, you're getting up into the tars and things like that. Okay, these are not going to be very, very long ones. So you don't get up more than about C12. Okay, so anyway, jet fuel, kerosene, coal, oil are names for the same group of hydrocarbons, and the answer is yes. All of them are hydrocarbons. And we're going to end right there and start off the next video doing the rest of it.